So I want to carry on with our conversation about chemical nomenclature by discussing our ternary or tertiary compounds. So these are the compounds that are going to contain those polyatomic ions that you should have a big list for. And so just to remind you, what is a polyatomic ion? Well, it's an ion that sort of comes as a group. So when a bunch of atoms group together to form an ion, and it's not a neutral molecule, it's an ion, it has a charge, then we call it a polyatomic ion. So for example, in this particular compound, calcium sulfate, I can see that calcium has a 2+ charge. Well, there must be a 2 negative charge on this whole thing, SO4. And the reason that I say that is because I see here that there are no subscripts beside my calcium and my sulfate. So they must have canceled out. So it looks like the 2+ and the 2- must have canceled out when I went ahead and did my crossover rule. Right? So just to remind you, that's what a polyatomic ion is. Let's carry out some examples so that we can remind ourselves of the details we need to be concerned about when working with these. So hopefully you already have this table handy, but just let's make sure that all of your formulas are correct. So ammonium has the formula NH4 with a +1 charge. Hydroxide is an OH with a -1 charge. Carbonate is CO3 with a 2 negative charge. Chlorate is ClO3 with a -1 charge. Nitrate is NO3 with a -1 charge. Sulfate is SO4 with a 2 negative charge. Hydrogen carbonate or bicarbonate is CO3 with a 2 negative charge. Bisulfate is HSO4 with a -1 charge. Acetate is C2H3O2 with a -1 charge. And phosphate, finally, is PO4 with a 3 negative charge. So hopefully when you checked your list, my values matched up with yours. Oops, I just see one mistake here though. Over here with my HCO3, that actually should be just a -1. All right. So we're going to use very similar rules to what we would with metal, non-metal compounds because we have ions that are involved. So for example, we're going to use our crossover rule and we're going to reduce to lowest terms as we have with metal, non-metal compounds. So let's take a look at this example. So here I have magnesium hydroxide. So hydroxide is something that I'm not going to find on the periodic table. So that's my cue to go ahead and look at my polyatomic ion chart. So I'm going to separate these by looking at their charges. Magnesium on the periodic table has a 2+ charge. And hydroxide on my polyatomic ion chart is OH-. And so I usually instruct students to put brackets around the polyatomic ion because this -1 charge right here applies to the whole polyatomic ion, and so I want to cross that down. And then this 2 charge here, when I cross it down using my crossover rule, is going to have to apply to the whole hydroxide, and so I put it outside of the brackets to indicate that. So let me remind you, I'm going to cross this 2 down outside here. This is understood to be a 1, so that's going to get crossed down beside magnesium. And so finally, when I get my formula, I will have Mg bracket OH bracket 2. So let's practice a few more examples. So here I have calcium nitrate. Now the 8 ending here I need to pay close attention to. That tells me that I have likely an oxygen-containing radical. That's one that's going to not be found on my periodic table. I'm going to need to look on my list, right? So nitrate is not the same as plain old nitride. So when I look on my periodic table, I see that calcium has a 2+ charge. And then I'm going to look on my polyatomic ion chart and see that nitrate has a -1 charge. So this is not going to be N with a 3 minus. It's different than that because the ending is 8. That tells me that I have nitrate. So I'm going to put brackets around my polyatomic ion. And then I'm going to cross down the charges. And finally, that will result in me having Ca bracket NO3 bracket 2. And I'm done. All right, so let's try the next example. So here I have cuprous sulfate. So again, we have some layers here. Right here I have this cuprous, and that's a Latin name with the OUS ending. And so that tells me I need to look on my periodic table and find copper with the lower of its 2 possible charges. So copper has a 2 plus charge over here on the side, or a positive 1. So it's +1 or +2. So I want copper with the lower of the charge because that's what the OUS ending tells me. So its lower charge is +1. And then sulfate is on my polyatomic ion list as SO4 with a 2 minus. So I'm going to put brackets around my polyatomic ion and then cross down these charges. And when I do that, I get Cu2 bracket SO4 bracket 1. Now, in class, we've talked a lot about how if you have a 1 outside of the bracket or a 1 beside something, then it's understood to be there, right? So in math, let me just take a minute aside here to remind you of something. In math, if I had 2 bracket x plus 1, then it's important that I have the brackets there because I'm going to be multiplying whatever I have inside the brackets by that 2 that's on the outside. However, if instead I have a 1 outside the bracket, let's make that a 4, then the brackets don't really need to be there because when I multiply by 1, I'm not changing anything. So in the same way, down here when I see my sulfate with the 1 outside there, that 1 doesn't really need to be there. And so if the 1 doesn't need to be there, then the brackets don't either. And so I can simplify this to simply Cu2SO4. Some people have asked if they can keep the brackets there, and that is fine by me this year. Although know that normally you would not see it there. Okay, let's try 2 more examples here. So I've got magnesium, which has a 2 plus charge. Carbonate tells me that I need to look on my chart to find out the formula for that polyatomic ion. I'm going to put brackets around my polyatomic ion and then cross down those charges. So remember how I said, let's just see what we get here. So when I cross that down, I get Mg2SO4 bracket 2. Now, as I said, this is an ionic compound. I have a metal with a nonmetal ion, or group of nonmetal ions, and so I am going to be able to reduce to lowest terms. So 2 to 2 is the same as 1 to 1. So I'm going to reduce that to MgSO4. And I'm done. Now let's look at this last example here. I'm going to move it up a bit and get to it. So ammonium phosphate. So ammonium is not on the periodic table either. It is on my list. And so when I look on my list, I see that ammonium is NH4 with a positive 1 charge. And phosphate is PO4 with a 3 negative charge. I'm going to put brackets around both of them in this case because they both happen to be polyatomic ions. So the 3 is going to come down, and the positive 1 is going to come down here. And so NH4 bracket 3, and then PO4 bracket 1. But again, as we mentioned before, that 1 in the brackets don't really need to be there because having those brackets does not change the formula at all. All right, so next part of this is going to involve us reminding you how to name each of the compounds that are in the list. So a good clue that you can look for to help remind you that some of these compounds are going to contain the polyatomic ions is you're going to see that there will be more than simply two elements in the compound. So for example, here I see lithium acetate, that says lithium, carbon, hydrogen, and oxygen, right? So I'm going to look on my polyatomic ion list, and I'm going to see that this thing right here is called acetate. And so next, I still can't forget about all my other nomenclature rules, which is to take a look at my lithium and see if it's monovalent or multivalent. Now, it turns out that lithium is in my group 1, my alkali metals, and so it will have a positive 1 charge only. So in that case, I don't need to bother with my Roman numerals. I don't need to bother with Latin names. I can just straight up call this lithium. And since my polyatomic here is acetate, it's just lithium acetate. All right, next. So here again, I can see that I have a polyatomic ion, so I'm going to go take a look at my chart and see what that's called. And when I look, I see that it's called phosphate. Calcium is also a monovalent metal, so this would simply be referred to as calcium phosphate. Okay, so the next example here, I have iron and I have this thing here. So this thing right here, when I look on my list, is called carbonate. So I'm going to put that over to the side here. Oops. And then I'm going to look at my metal. So in this case, it turns out that I have iron and it's a multivalent metal. And so before I can just simply name it iron, oops, I can't simply name it iron carbonate. I need to remember that it's multivalent, so its charge needs to be included in Roman numerals. And so I need to examine carbonate a little further. So carbonate, as it turns out, has a 2 negative charge. But I don't see that 2 down here beside iron. So that is caused by the fact that iron itself has a 2 positive charge. And so the 2 and the 2 would have canceled out and reduced this to lowest terms. So that's what's telling me that in this case I have iron 2 carbonate. Now another alternate name, of course, would be to use my Latin name of ferrum, right? So, but I need to figure out what my ending's going to be. So iron can be 2+, or it can have a charge of 3+. Now we've just established that in this compound I have iron with a 2+ charge. And so in that case it's the lower of the 2 charges. And you will remember that iron with the lower of the 2 charges will get the OUS ending. So this would be ferrous instead of iron 2. And then I finish off with carbonate, same as before. So there is your review of chemical nomenclature of ternary compounds. Make sure that you review all of this prior to your test, as it will be included, but also it becomes a part of other things that we have learned throughout the year, like chemical reactions and writing out chemical equations and predicting products as well. If you have any questions, be sure to come and see me so we can sort it out. Thank you.